Hello, everyone. Welcome to Methods 2, Week 5. This week, and for this assignment 3, we'll be working with topography and general landscapes. Uh, in class, we discussed the different methods and different ways to represent topography and especially contour lines. So if everyone can go to Canvas and download the Assignment 3 Topo Open from Module 5, Week 5, you should receive, or the model should include a general topography, contour lines of a landscape, as you can see here in my perspective view. That being said, all of these curves are open curves, and if we look in our right or front views, they're all equally spaced 1 foot apart. That's how we know that this is an accurate contour map and that we do not need to move these contour lines to represent their elevation. Um, this is akin to something you would get out of a GIS file or some other site survey file. What we're going to do first is determine the extent of all of these lines. That being said, I want to know how tall all these lines are, how wide, and how long they go. So what we can do is select all of the curves and type bounding box. And make sure that we have our options on. So output is solid, that's correct. If I turn this to shaded, now we see that there is a box here. I'm just going to go ahead and throw that into my box layer just for simplicity. And you can see that it changed colors. Now what you'll be able to notice is that top line is intersecting the top part of the box, while the bottom line is intersecting the bottom part of the box. If we go to ghosted, we can see that the extent of every line matches the extent of the box. You can see how all these intersect the edges of the box. This tells us a couple things: that the site that we're looking at is truly a box or rectilinear, and it will allow us to easily close these curves, which is what we need to do in a future step. But now that we see that all of these are workable, let's go ahead and turn off that box layer. Let's create a new layer and name this smooth surface. So now what we're going to do is select all of these lines, or let's select a couple first. Let's select just a couple to see what this command does. The command is patch. I'm going to preview, and we can see that this dialog box has opened up, and I've previewed what is going to happen. Right now it is estimating a surface that will intersect all of these curves. So if I do that again and I change these U and V spans, let's just say 40 and 40, and click preview, it will subdivide that surface even further and create a more accurate interpretation of intersecting all of those curves. So let's go ahead and cancel that and let's patch the entire surface. So we select all the curves, run patch again, 40, 40 is fine. We can keep these on or off. I'm going to turn off automatic trim. And we can see that we have this automatic smooth surface that encompasses all of those curves. but we see that it goes past our bounding box if we turn that back on, right? We only need the topography in this rectangle. But as we can see when we get close to the bottom here, and also at the top, because this patch is approximating the next curve or the next sequence, it's actually going above the box right now. We want to fix that by just selecting our box. We can use Gumball to easily scale the box in one direction along the z-axis. Now it confidently intersects all points. And what we can do is Boolean split. And we want to split the box using this patch surface. So I'm going to go ahead and select OK. And now what we should get is, if we delete this original surface, we should get this box separated into the shape of that patched contour, those patched contour lines. So I'll delete that top piece, and that is being the first model of this first part of the assignment. Now what I'm going to do is just hide this box. Well, actually, let's move that to our smooth surface layer so we know that that's taken care of. I'm going to hide that layer, and I'm just going to create a new bounding box. I'm going to zoom in on this. So now that we have this bounding box again, let's talk about how we can get the step topography, which is the second part of the assignment. One way that we can do that is, if I turn on this box again, we can see that in order to close this curve, we need to draw two lines that complete it. So all I'm doing is I have my O snaps turned on to hit the end points, and all I'm doing is tracing that box to where it meets this original curve. I can type join. But these are joined into one closed curve, as you can see in my object properties. Again, everyone, just for general visibility, I like to pull the layers tab to the bottom right and the properties to the top right. That way I'm always able to understand what layer I'm working in, as well as what the element I have selected is. For instance, this is a closed curve. Now we know that since this is a closed curve, we can extrude this curve, make sure to go only in one direction, and make sure it's solid. We can extrude it 1 foot. And now we can keep repeating that process for all the other curves as well. We can move this box down 1, down -1 foot. You can see this next line is darker now, meaning that it's intersecting it. I can redraw this line and this line, and then join them together and extrude them as needed. And we can keep doing that forever and ever. It may be a fairly slow process, so this is one way that we can actually get around that. I'm just going to undo back to where we were before with the open curves. What we're going to do is, again, have our bounding box. And this is a technique that is explained in the book on page 180, 11.2. And you can go through all of those steps, just the same as I'm going to do now. The only thing different is all they do, besides building this bounding box, they just draw a rectangle that encompasses everything. Since we already have this bounding box that encompasses all the contour lines, we can just duplicate this face border of this box, which will just copy that parameter outline. And I'm going to make a new layer and call it rectangle. And make sure that that rectangle is in that layer, as it is shown right here. Let's just make that a different color so we can keep track of it easily. So now what we need to do, we need to array linear. And we can do that a couple ways. We can first measure how much we need. There's 36 feet, so that means there's 36 lines. And we can take this green rectangle, array, linear. I'm going to go ahead and leave this box on just for more easy way to snap to things. And we know that, again, what I said was 36. Let's do 37, just so we have one layer that is flat at the bottom. So it's asking me for the reference point. We're going to go from the top, and we can see the preview, right? We're going to go to the bottom. Oops, let me do that again. So if I array linear, 37, I'm going to, instead of clicking, I'm going to hold Shift and Tab. It locks me in the Z direction. And now I need to type the distance that I want all these to be separated by. I'm going to type 1 foot. We see how they are all separated 1 foot away from each other along this box. I'm going to turn off the box. And now what I'm going to do is select all of these lines and type intersect. All this is doing is highlighting the points that your contour lines and the guiding rectangle are intersecting. What we can do now, since we have these points selected, we can just type trim and start trimming the curves that we know are not legitimate. By that I mean, we know that the high point of the contours are over here, and so this part of the rectangle is not needed. So I'm just going to select all of these quickly. There we go. Now that we have all of our rectangles trimmed to their appropriate curves, what I can do is select those points again by SELPT, and I can delete them because we no longer need them, and I can join all these curves together. And now if I look at my properties, it says 37 closed curves. That is good, so now we know that we have all of our curves closed. What I'm going to do is select all those curves again and just extrude curve. Next, be sure to extrude it 1 foot. And that is the second part of your model done. Now the third part, which is a view display or a viewport property, is we want to make sure that we have a perspective eye level view. So what I'm going to do easily to get that approximate 6 foot high person viewpoint is I'm just going to draw a cylinder and make it 6 foot tall. I'm going to go to my shaded view for this, just so I'm not snapping or selecting anything else. And I'm going to decide where I want that. Maybe I want it at the bottom of the hill. And for this, you need to make sure that your projection, your viewport projection, which is over here, is in perspective and not parallel. If it's in parallel, then this will not work. So if it's in perspective, we can right click on our viewport go to Set Camera, then go to Place Camera and Target. So we will place our camera at the center. Make sure we have our center post map turned on. At the center of the cylinder. Then we can select anywhere that we want to focus the camera on. Let's say I want to focus the camera up at the top of the hill. So now I am at the bottom of the hill looking up. Maybe this is fine for the stepped, or maybe I decide that this doesn't look good with stepped. Maybe this would actually look better on the smooth surface. So if I turn that on and turn off this, now this is kind of what it looks like with the smooth surface. And maybe shaded looks better. And I can throw that into my layout tab and label it appropriately. Whenever we move further into the semester, it'll be very nice to create both types of landscape models. Primarily, we would use a smooth surface for creating renderings. That way we have a more realistic or semi-realistic view of what the actual landscape will be. For instance, if I do turn on my step terrain again, and I start rendering this, each contour line will produce a little shadow, which is not accurate to real life. But the smooth surface will be a more realistic interpretation of that surface. But where we can use step topography is stuff like site plans or floor plans or stuff that are more 2D based. We can also use it, you'll also use it more whenever you start building models and needing to 3D print or laser cut your topography. We can imagine that each of these topography lines is a layer of chipboard or a layer of cardboard, right? That is it for this assignment. It's fairly light compared to the last assignment, and hopefully that will allow you to finish your last assignment in time for the next part of assignment 3. Thanks, everyone.